Hey everyone, welcome back to Liceo Math Club tutorials. Together with my partner Ralph, today we will be discussing about trigonometric identities. Before everything else, if you haven't subscribed to our channel yet, be sure to hit up that subscribe button and hit up the notification bell to stay updated about our latest posts.
Table of Contents: Reciprocal Identities, Quotient Identities, Pythagorean Identities, Negative Identities, CoFunction Identities, Sum and Difference Identities, Double Angle Identities, and Half Angle Identities. Let's start with trigonometric identities, a statement of equality involving two or more trigonometric functions which is true for all values of the variable for which both sides of the equality are defined. Reciprocal identities. The reciprocal means flipping the numbers. The reciprocal of the fraction. In general, the reciprocal identities are identities in which the equality relation occurs by swapping or interchanging the numerator and the denominator of the number. Cosecant is equals to 1 over sine. Secant is equals to 1 over cosine. Cotangent is equals to 1 over tangent. For example, what is cosecant if sine is equals to 1/2? Cosecant is equals to 1 over sine. So by using the formula, cosecant is equals to 1 over 1/2 by substituting the given into the formula. For the third, get the reciprocal then multiply. So cosecant is equals to 1 times 2. And the answer is cosecant is equals to 2. Quotient identities. Quotient identities refer to trigonometric identities that are divided by each other. There are two quotient identities that are crucial for solving problems dealing with trigonometry, those being for tangent and cotangent. Cotangent, if you're unfamiliar with it, is the inverse or reciprocal identity of tangent. Tangent is equals to sine over cosine. Cotangent is equals to cosine over sine. So for example, find the tan and cotangent if sine is equals to 9 and cosine is equals to 3. By using the formula, tangent is equals to sine over cosine. And substituting the given values, tan is equals to 9 over 3. So let's solve it. Tangent is equals to 3. Use cotangent for the formula next. Cotangent is equals to 3 over 9. Pythagorean identities. The Pythagorean trigonometric identity, also called simply the Pythagorean identity, is an identity expressing the Pythagorean theorem in terms of trigonometric functions. Along with the sum of angles formulae, it is one of the basic relations between sine and cosine functions. Cosine squared plus sine squared is equals to 1. Tangent squared plus 1 is equals to secant squared. 1 plus cotangent squared is equals to cosecant squared. So for example, if sine is equals to 2/3, what is cosine? By using the first formula, cosine squared plus sine squared is equals to 1. Substitute it. Cosine squared plus 2 over 3 squared is equals to 1. Transpose and solve. Cosine squared is equals to 1 minus 2 over 3 squared. Get the square roots. Square root of cosine squared is equals to square root of 5 over 9. And the answer is 5 over 3. Negative identities. Negative angle identities are trigonometric identities that show the relationships between trigonometric functions when we take the trigonometric function of a negative angle. These identities are as follows. Sine minus angle theta is equals to negative sine, or cosecant minus angle theta is equals to negative cosecant. Cosine minus angle theta is equals to cosine, or secant minus angle theta, or secant. Tangent minus angle theta is equals to negative tan, or cotangent minus angle theta, or equals to negative cotangent. So for example, negative sine minus 2 is equals to negative sine 2. Negative cosine minus 2 is equals to cosine 2.
CoFunction identities. They are identities showing the relationship between sine and cosine, tangent and cotangent, and secant and cosecant. The value of a trigonometric function of an angle is equal to the value of the cofunction of the complement of the angle. The cofunction identities are as follows. Sine 90 degrees minus theta is equal to cosine theta, or cosine 90 degrees minus theta is equal to sine theta. Tangent 90 degrees minus theta is equal to cotangent theta, or cotangent 90 degrees minus theta is equal to tangent theta. And lastly, secant 90 degrees minus theta is equal to cosecant theta, or cosecant 90 degrees minus theta is equal to secant theta. I know it might seem complicated, but they really are just the inverse of one another, like how sine is the inverse of cosine, tangent and cotangent, secant and cosecant. For example, we have, if sine theta is equal to 12 over 13, what is cosine theta? So first we have to write down the given and solve for the angle, which is the theta. To do that, we need to isolate the theta on one side by transposing the sine to the other side. And so now we have arcsine 12 over 13, which is approximately 67.38 degrees. Now if you want to check your angle, just substitute it to the given right here, and so we have sine theta is equal to 12 over 13. So it's sine 67.38. If you hit up your calculator, it should be approximately 0.923, which is, in fraction form, 12 over 13. Next step, substitute the angle that we got, and the formula that we're going to use here is this one. And so now we have cosine 90 degrees minus 67.38 is equal to sine 67.38. Next step, simplify. So 90 degrees minus 67.38 is equal to cosine 22.6, and solve. And so is equal to cosine 22.6 degrees. And this is our final answer. Sum and difference identities. They are trigonometric identities which show how to find the sine, cosine, or tangent of the sum or difference of two given angles. Sum and difference identities are as follows. Sine x plus or minus y is equal to sine x cosine y plus or minus cosine x sine y. Cosine x plus or minus y is equal to cosine x cosine y minus plus sine x sine y. And lastly, tangent x plus or minus y is equal to tangent x plus or minus tan y over 1 minus plus tangent x tangent y. For example, we have what is sine 105 degrees. So first we need to get the additive value. So basically we need to find two different numbers, whereas when added is equal to the number inside the given parenthesis, which is 105. So now we have sine 60 degrees plus 45 degrees, because when added together it's equal to 105. So we have 60 degrees as our x and 45 as our y. So next step is to substitute and solve. So the formula that we're going to be utilizing for this one will be this. So we have 60 for our x and 45 for our y. So we're going to substitute that one, and so now we have sine 60 degrees plus 45 degrees is equal to sine 60 cosine 45 plus cosine 60 sine 45. So simplify that, and we will end up with our final answer, which is sine 105 degrees is equal to the square root of 6 plus 2 over 4. Double angle identities. They are trigonometric identities that show how to find the sine, cosine, or tangent of twice a given angle. The double angle identities are as follows. Sine 2 theta is equal to 2 sine theta cosine theta. Cosine 2 theta is equal to cosine squared theta minus sine squared theta. Tangent 2 theta is equal to 2 tan theta over 1 minus tangent squared theta. For example, find the exact value of sine 2 theta if the theta is equal to 13. So to prove the double angle identities, we are going to utilize this formula. So we substitute the given, which is 30 degrees, So now we have sine 30, cosine 30, and solve. Sine 30 is equal to 1/2 and cosine 30 is equal to the square root of 3 over 2. So 2 times 1/2 times square root of 3 over 2 is equal to square root of 3 over 2. Our final answer would be sine 2 theta is equal to square root of 3 over 2. Half angle identities. They are trigonometric identities that show how to find the sine, cosine, or tangent of half a given angle. The half angle identities are as follows. Sine theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2. Cosine theta over 2 is equal to plus or minus the square root of 1 plus cosine theta over 2. For tangent, we have 3 different identities. First, we have tangent theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. Second, tangent theta over 2 is equal to plus or minus sine theta over 1 plus cosine theta. And lastly, we have tangent theta over 2 is equal to plus or minus 1 minus cosine theta over sine theta. For example, find the exact value of sine theta if theta is equal to 15. So first we need to rewrite the given to fit the formula. So since we're dealing with half angle identities, we need to find a number, whereas when divided by 2 is equal to the given, which is 15. And so we have sine 30 over 2. For this one, we are going to be utilizing this formula. Next step is to substitute. So we have sine 30 over 2 is equal to plus or minus the square root of 1 minus cosine 30 over 2. Next is to solve. So keep in mind that cosine 30 is equal to the square root of 3 over 2. And so we plug that in right here, and 2 times 2 is 4, and so we have plus or minus square root of 2 minus square root of 3 over 4. Simplify and then we get approximately 0.2588, and this will be our final answer. And that is it for today's video. Don't forget to hit like and subscribe for more video tutorials.